So, welcome to third part of Unit 5. Uh, in this lecture, I will be discussing topics like high strength concrete and fiber reinforced concrete. Okay. So, what is high strength concrete? First of all, high strength concrete is also known as high performance concrete. So, concrete with high durability as well as high strength is known as high strength concrete or high performance concrete. So to call it as high performance concrete, it should exceed a strength of 80 megapascals. Okay. So the compressive strength 28 is compressive strength should exceed 80 MPa. Okay. So composition consists of good quality aggregates, obviously cement, silica. We have silica fumes. Then we have water, fly ash or GBS, as you already studied, and then you have super plus sizes. Okay, so as you can see in this figure, this is normal cement, and then after hydration you have some spaces left here and there, like these voids are there. But when you add silica fumes and after hydration, you can see there are no, let's say, voids. So the concrete is very durable, impermeable. Okay, the finish is very good, there are no cracks. Okay, so the most important thing in such concrete is low cement ratio. Sorry, water cement ratio. Low water cement ratio. It is often around 0.25 and sometimes below it, also close to 0.20. And for this reason we always use super plasticizers. Okay, this is a kind of admixture we will discuss in unit 4. Okay, so just understand it, increase the lubrication of the concrete, so it increases the workability of concrete. Easily it can be mixed, as the water cement ratio is very low. The mixing of concrete or the workability is very poor, and to overcome such problems we use super plasticizers. Okay, this is a kind of admixture we will discuss in future classes. So it is very dense and has very low porosity. Okay, so as you have seen, the water cement ratio is very low and not enough for full hydration of cement. So even after curing in water, a good amount of, or a substantial amount of cement remains unhydrated. So even after curing, we have some cement which has not been hydrated, so it is still in cement form. So, what are the advantages of such concrete? The first advantage is that concrete column sections, they can be reduced in size, or if they are not reduced in size, the reinforcement can be reduced for the same size. So if you reduce the reinforcement, you save money, and or if you reduce the column section size, you increase the floor area. So in a given room, if the columns are of small dimensions, you will have more area in the room. So obviously, advantages are there. For example, let's say we take an example of a city like Mumbai. We do not have the luxury of space there, so we want structures which have very efficient utilization of space can be done in such structures. So we can use high performance concrete to have thinner sections of column, so the floor area is increased. So the next advantage is there is very little cracking, and even the fracture surface is very smooth. If you break in two parts, the two surfaces exposed are very smooth. The heat of hydration is low. There is low bleeding and plastic shrinkage, and obviously because of these factors, the durability is very high. Okay, the structure will last for a longer time. So the next topic we have is fiber reinforced concrete. So fiber reinforced concrete for short, I will be calling it FRC. So you can see FRC, fiber reinforced concrete. So it is made up of hydraulic concrete, sorry, hydraulic cement aggregates and discrete reinforcing fibers. Discrete reinforcing. So for example, in this sample, you can see this is the cement and aggregate thing, and then we have very small fibers here. Okay, this is called discrete. Okay, not in a proper shape, very uh, randomly distributed and small in shape. This is called discrete particles. So so these fibers can be of different materials. For example, we have steel, glass, organic polymers, and even synthetic fibers also we can use. Okay, so steel, you have to remember here, we already use steel as reinforcement in our beams and columns, and you will be studying RCC, reinforced cement concrete, in your next semester. But this is not the steel which you are talking about. This is different steel we are talking about. I will just discuss in the next slide how it is different from the reinforcement we use in beams and columns. So naturally occurring fibers, for example, asbestos, vegetable fibers. Then we have jute. They can be used as reinforcement. Obviously, the mix is always cement, mortar for the base material. So if you use such fibers in a proper way, I say proper because you cannot use it above certain proportion. So it's not that you are using, the more fiber you use, the better structure. It is not like that. Up to a certain limit, the strength can be improved. After that, if you use the fiber, the advantages they start decreasing. Okay, so if used properly, uh, they can give long term serviceability and other benefits also. Okay, so what is serviceability? So you will again you will uh, study this concept in your RCC. uh, the serviceability of a structure. Let's say, you can give an example, for how long the structure can be used, or it provides you essential, what you call value, for how long it is valuable. So if it cracks after certain time, or it fails after certain time, then it is not serviceable. Okay, so you will learn about these things in your next semester. uh, So what we see is that using concrete fibers, there is improvement in post-cracking behavior. Okay, so as you know, cracks will appear when you are using concrete due to shrinkage and creep. All those things, the cracks will appear. But post-cracking also, if you see the concrete having fibers, has a better, behavior compared to concrete not having any fiber. The point here is, they do not improve the ultimate tensile strength, but they do improve the tensile strength. Okay? And the structure is more impact resistant and tough structure we get compared to normal concrete. So as we know, concrete is a very brittle material, and it is primarily used for its compressive strength, not its tensile strength. So usually we use steel bars for tensile strength, so that's called RCC. But if you use these steel elements or glass fibers in randomly distributed manner, then even the tensile strength can also be improved up to a certain limit, obviously. Okay, and the main purpose here is energy absorption. So toughness is the main idea behind the use, and obviously tensile and flexural strength, they do improve, but main advantage is of toughness. So for applications, we can use such concrete in thin sheets, roof tiles. We can use in, okay, they are very durable. Then we can use in pipes, prefabricated shapes, panels, shotcreting. So what is shotcreting? So if you see in this figure, this is a retaining wall being constructed by spraying concrete over the reinforcement. So it is done in this manner, you see. So this places as well as compacts the concrete, and it is very suitable for such structures which are vertical in shape. So this concept is called shotcreting. Okay, shotcrete or shotcreting. It can be used. It can be seen in uh, tunnel linings. If you see projects in hilly areas, uh, they use shotcreting for tunnel lining. Then we can use it as curtain walls, slabs, precast elements, composite decks, walls, safes, and impact resistant structures. Okay, so these are the applications of FRC or fiber reinforced concrete. So for the fiber now, what is fiber? Fiber is a small piece of reinforcing material possessing certain properties. So how would we define the parameter? Uh, So the fiber is often described by a convenient parameter called aspect ratio. So what is aspect ratio? It is defined as the length of fiber to its diameter. So aspect ratio is the ratio of length of the fiber to its diameter. Okay. So it usually ranges from 30 to 150. Okay. And steel fiber is most commonly used fiber. Okay. So again, as I told you, steel is most commonly used fiber. So this is the shape I was talking about. We do not use steel as you have seen steel bars. That is a different thing. That is an enforcement RCC. But using steel in random small particles, sorry, parts. This is the shape I was talking about when you use steel as fiber. Okay. So obviously it improves a lot of uh, characteristics of concrete. Then we have glass fiber reinforced concrete or GFRC. Glass fiber reinforced concrete or GFRC. So we use fiberglass, fiberglass and or fiberglass materials in small particles, or sometimes sheets like this. We have this is GFRC sheet. You can see. So primarily they are used in cladding of buildings. So in this building you can see this is the material used. GFRC is used here for cladding of the building. Then we have permanent temporary formwork, pressure pipes. We can use it in pressure pipes. The inner lining of pressure pipes can be made up of GFRC. Then we have doors and frames. Then we have decorative grills. You must have seen buildings having such kind of structure. These are called decorative grills and they are made up of GFRC. They are commercially available if you check on Google, and they will give you a rate at which it is available. So this is currently being used in the construction industry. Then we can construct bus shelters, park benches, So these are some of the uses of GFRC. So in place of steel or glass, you can use synthetic fibers also. Okay. So this is a synthetic fiber, nylon or some other material we have, and this is the raw material, raw form which is being used, and then you see how it is added in the concrete. This is one of the cross section of the member where this has been used. So technically, reinforced concrete or this fiber reinforced concrete has been used before RCC. It has been used in past times also, but currently it can be used in all the elements of the structure. Okay, but uh, but you have to keep in mind that it cannot be used beyond certain limit, which we will discuss in future classes. What is that limit and how it does it impact? And a lot of research has been done in a department using fiber. reinforced concrete and all those things. Currently, there are some of the students are working on these things, so you can get in touch with MTech students and have some knowledge about these things. But a very simple example you must have seen in your let's say in your villages or wherever you live maybe, um, that people use husk or these material hay or husk in mud, making some mud structures, like pots and all those things. Sometimes they use it to give it some strength. So technically, that is the concept being used in concrete. So it is an old concept, but now being used in concrete also. So in recent development, we have high fiber volume microfiber systems, slurry infrared fiber concrete, SIFCOM, compact reinforced composites. So these are some of the fields which are being worked upon. And if you are interested in concrete technology, or if you pursue a career in this field, in the field, or maybe in the research part, you can you will obviously face these things, and this is some of the current research and development going on in this field. Okay, so thank you for your attention. You should go through the Google Forms for your attendance. I will be posting some questions. Uh, Answer those questions to ensure your attendance. And if you have any questions regarding Unit 5, you can post it on Google Classroom, and I will try to answer them. And as soon as we open up for our regular classes, you can ask any topic if you find it difficult to understand, any problem, language, anything. I will be explaining them again maybe. And so feel free to ask any question. Okay, thank you very much.